Hey guys, this is sheet 7 of Conic sections. Title block just about cut off down here. So sheet 7, first of all, to read the question, the plan and elevation of a cone are shown below. The cone has been cut by the plane SS as indicated. Complete the plan of the cone and determine the true shape of the cut surface. So complete the plan, determine the true shape. Now the first thing I'd like to establish is what object we are cutting a cone at a certain angle. What angle are we cutting it at, and what is the resulting shape that we are going to find from the cut? So I'll just check, is that plane parallel to the edge? Yes, it is. If that plane was not parallel to the edge, we might be getting an ellipse if it was an extended cut, but it's parallel to the edge, which means it's cutting and forming a parabola. A parabola is an open-ended curve. So the first job I'm going to do is say, right, well, that is the circular profile as it lies on the ground. That is where it cuts out of that profile. So it gives me a straight line right there. This extreme generator to the left, this one gets cut here. As for the rest, I can really do it any way I want. I can use multiple horizontal sections, which gives me some circles down below, and I get my cut points in the circle. Or I can use generators. You can do whatever you want, really. I'm going to go with the generators for this. I'm going to draw a selection of generators here. Now, I've just drawn, so I'm going to go, actually, sorry, I should go further with these, of course. I should draw the rest. Because, of course, it is cutting both sides of this cone. So, working from the apex, I'm going to call it 0, up there up top, down. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12 generators in total. If I project all of those points up, so point 1 is already up there, it's the extreme. There's 2 and 12, 3 and 11, 4 and 10, 5 and 9, 6, 8 and 7. There's 1, there's 2, sorry, I should say 12,2 because 12 is the one out near me. 2, 11, 3, 10 and 4, and that's 9 and 5. Now, what you'll see here is that the rest are outside of the section. They're not going to give us any information. They're not contained within the object or within the cut. They're actually outside the section. So 6, 7 and 8 are all out here. They're no good to me. So what I'm going to do is I'm going to just draw the elements of the generators first. So there's from the apex down to 10, 4. There's the apex down to 9, 5. Down to 11 and 3. And finally down to 12 and 2. At this point I can see where everything gets cut. The extreme generator number 1 gets cut there. The generator going from the apex down to 2 and 12 get cut there, down to 11 and 3, down to 10 and 4, down to 9 and 5. So I have all my cut points, so I can project them down to plan. So the numbers 5 and 9 get cut at that point, which gives me 2 points in the curve. Now 10 and 4, that gives me nothing. I'll get back to those. 11 and 3. 11 here and 3 here. And finally 12 and 2. Now, next job. For number 10 and 4, they lie here. I look up along and I see them in elevation, but I can't see how far out they are from the apex. So what I'm going to do is this. I'm going to create a section cut. I'm going to cut horizontally through the object at that point. A horizontal section through a cone will give me a circle. So I'll just take the radius of that circle down, and I'm going to draw that circle in plan. Semicircle is plenty. No need to draw the full thing. So where I just put my pink horizontal section right here, that gives me this profile, this circular profile. So my horizontal section gives me a circular profile, and that circular profile gives me 1, 2 points. And that's my section cut as it appears in plan. Now, where are we? So I start joining the dots here, and then it all the way out onto the ground. So that's the curve as it appears in plan view. What have they asked us next? They've asked us complete the plan of the cone. Done. Determine the true shape of the cut surface. There's two ways of finding your true shape here. We can use an auxiliary view, or we can use rabattment. Now I'm going to do both, but I'll start off with the auxiliary view. If you can see an edge view of a surface like we can see up here, if you can see an edge view, you can look at 90 degrees to the edge view and you can get a true shape. So I'll start off with that one. So I'll just set my adjustable up, make it a little bit faster here, and I'm going to just project all points off at 90 degrees to that edge view. Now they're nicely highlighted there for me in red. Make it nice and easy to see the points. You can take any number of points you want for this, but I suppose what we have here, the number that we have already on this question, will make it nice and accurate. I'm not going to use an x1, y1 line out here and reference everything. I'm going to use like an x1, y1 center line through the object. That center line I've projected from an elevation, so this is a plan. The widths here will be referenced from the widths here, and they will all be referenced from the center lines. To establish the widths, I'm going to start with the widest points down the ground and make my way all the way up to this one single point up top. So we're looking for an open-ended curve here, a parabola. So widest points on the ground, and it's symmetrical, so up and down is the same. So I can go ahead and mark to the left and the right of the line. Working on my next red point, I'll bring it down to the center line in plan and work up and down to the red marks. And I'm going to repeat that for all remaining points, so the ones here 10 and 4. Now it's going to get quite tight here. I might have to skip one set of points because I'm not sure if I'll be able to set my compass that small really. I'll do the next ones, which were on 11 and 3. This with the top point, with the second point, with the third point down. That is kind of as close as I want to be going with my compass. I don't see the point in doing any more. Once I have those two right there and there, well, I think I'm going to just go ahead and drop in the curve. There's no real advantage to having extra points up here now. And there's my true shape right there. So, true shape of the cut. As I said, the second method, if we're looking at the edge view, and if we can see, much more importantly now, right there, that line on the ground is a true length, and when you look up along the true length of the line, you get a point view of the line. If I can see the point view of a line on a surface, I'm seeing the edge view of a surface, and I can rabat the surface about that point of view. So some of you may prefer this method. So I can go ahead and I can rabat about that red point view of the red line. I can rabat all my points. There. I will project them down to plan. And when we complete our abutment, all points move perpendicular to the hinge line. So that was the hinge line right there, highlighted in red as a point view. All points move perpendicular to the hinge line. So I know that we can probably, if we're used to this, we can do it really quickly. This point goes up and around onto the first line, and so there's this point which is corresponding. The next point there goes up and around onto the second line, and so there's this one. Next points, so it's getting a little bit harder to see here now. Next point there, very top of the object, so there. I'm going to drop down one space. I'm going to drop down one more space, and there we are. There's the true shape of the surface right there if I join my dots now. There we are. True shape. So 2 different methods of finding the true shape for this. When we are presented with our edge view, we can either look 90 degrees to the edge view for a true shape using an auxiliary plan, AUX plan. That auxiliary plan was all referenced off a central X1, Y1 line, referencing the center of the object, so that the symmetrical dimensions left and right can be taken from the plan and applied up here. The second method, when we can see our edge view and we can see a true length line as a point, or we can see a trace in this case as a point, we can drop it down onto the plane, bring it down and move everything perpendicular to the hinge line, and we get our true shape. Hope this helps.